we're kind of remembering all of these things, right? Let's go back into our actual course and look at today's folder. I think we're going to go to the digital notebook. Here we go. Oh, I know what I wanted to talk about first. Those discussion questions. How'd we do on the discussion questions from yesterday? Some of.
Thank you. The drill is now over. Have a great day.
So lots of people did these. Were there any that people had questions on? Any that we want to go over? If you haven't had a chance to do them, please do them. They're counting for extra credit for quarter 2. So some extra points here to boost a grade if you're like right on that cusp. Speak now or forever hold your peace. Anybody want to talk about any of them? For quarter 1.
So those aren't graded, only extra.
Yeah, they are graded. They are extra credit, but I still want you to do them.
I'll do
them. Do we need to talk about the homework from Friday? Because that looked really good too. There weren't any questions that jumped out at me as being below 70%, which is usually kind of my threshold for reviewing. Any questions if you open up Friday's homework 2 that you want to go over? This is your opportunity for this to be your class. So I'll give you a second to go check that. I'll go check it too and see if I'm. I did, yeah. So all I see is still stuff from. So yeah, 75, 90. Yeah, it all looked good. So if nobody has any questions, we'll just go into our notes for today. Okay, so I know I have you skip around a lot, but we are going to go to the digital notebooks. If you want to open your copy. We've already done all these angle relationships. So we're going to talk about slope. And it should be kind of an easy day because slope you've done before, right? Slope's nothing new. No, we're going to do those tomorrow. Yeah. No craziness. We are going to skip down to slide 12, and we're going to skip over 10 and 11. I've changed things a little bit this year. We've got a positive slope. So, okay, when you look at a line, I want you to always read from left to right. Just like we read books from left to right, we're going to read slope from left to right. So if you're looking at the slope from left to right and it's going uphill, that's a positive slope, right? If you read from left to right and it's going downhill, that's a negative slope. A zero slope, I think of a zero as a ball. I've got big dogs at home. We love to play fetch. This is just my weird brain. With zero slope, that ball, that zero can sit on the line. That's how I remember a horizontal line is zero slope. And then undefined, that ball is going to fall under my couch, under my deck. It's going to be somewhere where the dog can't find it. It's going to go underneath. So it's undefined. Okay, it's just my weird brain of how I remember things. So reading from left to right, positive goes up, negative goes down. Zero, the ball will sit on the line, and undefined, the ball will go under the couch. Undefined, under. We're going to do rise over run. We rise on the y-axis. Okay, so if you remember rise over run, we rise on the y-axis, and we run on the x-axis. Again, you've got these little subscripts, so y2 minus y1 and x2 minus x1. It doesn't matter which point is first and which point is second. Again, I usually go from left to right, just to make sure that it always kind of makes sense. If you're going down, it's negative. If you're going right, it's positive. If you're going up, it's positive. If you're going left, it's negative, right? So any negative sign is just going to kind of float around. Negative 5 over 3 is the same as 5 over negative 3. Any questions on this right or on this left side over here? This is like all straight up review. Okay, and we did touch on it when we did distance and midpoint. I just didn't test you on it. Okay. You might want to write yourself a little note right here. That's what this yellow box is for. How do you decide whether it's positive, negative, 0, or undefined? I've told you my weird way because I have dogs and I think about throwing tennis balls, right? How I remember 0 and undefined. You might want to figure it out a different way, or maybe another teacher taught you a different way, right? Put a couple notes in here just so you know the difference between positive slope, negative slope, 0 slope, and undefined slope. You got the picture, but you need to link it somehow in your brain so you'll remember. I'm just going to give you a minute to write yourself a little note right here on the left side. Yeah, these are your notes. So whatever makes sense in your brain, and not everybody's brain is the same. So it's gonna, like, this can vary. There's no right or wrong here. And then in the second part, how are you gonna remember that the y's go on top, right? We just did midpoint, we just did distance. All three of these formulas have x's and y's. They all have two pairs. But this one is the one that's different, where the y's come first. So how are you going to remember that the y's are the rise and the x's are the run? Put those right here. 9 times out of 10, if somebody gets this wrong, they put the x's first instead of the y's. So that's like number one mistake that happens. It's kind of silly error. And then we're going to jump over to question number 1. If you're given a graph, you can start at that leftmost point and then go 1, 2, 3, 4. All I'm doing is counting that distance, right? Just like when I do Pythagorean theorem. And then 1, 2, 3, 4, 5. This slope is positive 4 because it's going up, and positive 5 because it's going right. So the slope is 4 over 5. This is my favorite way. I like just counting on the graph, right? There is a trick. It's like playing the floor is lava. You have to walk on the lines. You can't go off road at all, right? A lot of people like the algebra though. So if I do my x's and my y's, we just got to remember that formula, y minus y. So 5 minus negative 1, that's a 5. And then negative 2 minus 6, negative 2 minus 6. So we're going to get 5 minus negative 1, it's negative 6. Did I do that right? And then negative 2 minus negative 6 is negative 8. And that is a 6. I just can't read it right. So this is going to be 3 over. Negative 2 minus positive 6, right? Yep. 2, 1, 2, 3. Oh yeah, so these points are not the same. They're not going to match. I was thinking, what did I do wrong that they're not matching? So this is 3 over 4. Try the next one on your own. Let's all do it. You do it. Let's see if we get the same answer.
So when it's going right.
Yes. So think about the number line. It's up is where the positive numbers live, and right is where the positive numbers live, and left is where the negative live, and bottom is where the negative live. Yeah, Lily. It doesn't matter. So you just need to decide which point you're going to start with, and they have to be stacked. So the negative 2, 5, I put first, and the 6, negative 1, I put second. But you could have done it the other way around. Like with this one, let's start with the h. So we'll do 7 minus negative 3, because we do y minus y. And then I can come over and get a different point, right? Because I started with the 7, I've got to start with a -6. -6 minus -11. Right? So here I did this point first. And here I did this point, or this point first. So it doesn't really matter. It's whatever makes most sense to you. And honestly, I try to do it so I have the fewest negative numbers. And this was a +6, so that was -4. That was not clear.
-4.
Mm-hmm. Because that's a -8. This is the first one. It should be 3 over -4. Right? This one is going to be +10 over +5. Did I do that right? And then what is 10 over 5 reduced to? 2. Okay. And if we come over here, we're going to do the same thing. If you're on the graph, you start with a P, and we're going to go down 1, 2, 3, and write 1, 2, 3, 4, 5, 6. So down 3, right 6 would reduce to -1/2. Questions? Did everybody get -1/2 and 2 for number 2? Try 3 and 4. Oops. So on the left side, my ordered pair is different. So this ordered pair was 1, 2, 3, -3, 4. Yeah, so I thought the ordered pairs were going to be the same too. It's going to be like the same problem, but different. Yeah, it's not. You don't have to simplify them, but frequently you're going to be asked to simplify them.
Going down -1 over 2.
So if you go down, like this is -1, 2, it's going to make the stair step smaller. It's going to make similar triangles. So if I go down 1, right 2, down 1, right 2, down 1, right 2, I just have to do that 3 times. It's the same slope, it's just smaller numbers. The green and the pink are going to get me to the same spot. What about question 3? How do you know this is undefined? Because it's a straight line and it's going, is that vertical or horizontal? Vertical. Another way to remember is some teachers teach bucks. Do you remember Hoy and bucks? Vertical, undefined, x equals. Vertical, undefined, x equals. Familiar? No? No? Okay, we'll talk about that then too. So vertical lines are up and down, and they're going to be x equals equations. This is an x equals +1. So this is a vertical line, it's undefined, and it's x equals. I'll make some notes on that tomorrow. Vertical, undefined, and x equals a number. So in this case, it's x equals 1. But it is undefined. What ordered pair are we going to start with over here? We are going to start with the y's. We want to start with -4 or with 2? It doesn't matter. So we'll start with -4. -4 minus 2. And then we'll go to the y's, or the x's. So if I start with the -4, I got to start with 9. So 9 minus 9 And that's going to give me -4 minus 2 is -6 over 0. So is that 0 slope or undefined slope? Undefined. The 0 is under the fraction bar, so this is also undefined. You cannot divide by 0. That's like a big no-no in math. Okay, so if the 0 is under, it's gone under the couch, it's undefined. It's another reason why I think about the balls. Here, is this a 0 slope or an undefined slope? 0 slope. That ball will sit right there on the line. This is a Hoy line, so horizontal, 0 slope, and the equation is going to be y equals, in this case, it's y equals 4. So this is a Hoy line. So usually algebra teachers use Hoy and books. Maybe you guys just didn't get to that last year because of virtual learning. So if I started with the -4, let's start this one with the -3. -3 minus -3. So make sure you're careful about those signs. -3 minus -3, and then 0 minus 7. 0 minus, -7. So -3 minus 3 is like -3 plus 3, which is going to be 0. And then 0 minus -7 is going to be like 0 plus 7. So is that a 0 slope or an undefined slope? This one is the 0 slope. The 0 is sitting on the couch. It's sitting on that horizontal line, right? So this one is the 0 slope. And there was a message in the chat saying, can we go look at number 1? So let's go look at number 1 again. Did I make a mistake in number 1? 1, 2, 3, 4. 1, 2, 3, 4, 5. Up 4, right 5. 4 over 5. I'm looking in the chat. Okay, just wanted to make sure.
Could you go back down to the last one and explain that again?
Yeah, absolutely.
Because I did it the other way that you could do it. It's the same on the top, but different on the bottom.
It is. So did you get 0 over -7?
So it's 0 because you're -3. You're saying so 0, yeah, 0 over -7.
Yep. So 0 over -7 is still going to be that 0 slope. And when you have a 0 slope, depending on which way you do it, you're going to get the denominator is either going to be positive or negative usually. And usually it'll be the same number, but you're going to get different signs. But that 0 on the top, because 0 divided by anything, positive or negative, is always going to be 0. That denominator just doesn't matter. Yeah, you're welcome. Yeah, Mason. I'm a very visual person, so I will plot everything on a graph and do this left method, looking at the graph, before I'll do the algebra, because I make lots of little tiny mistakes with algebra. Some people really like the algebra, and they get lost in the graph. So you just have to kind of know how your brain works and which way is better. But I agree. I would plot those points and notice that -7, -3, and 0, -3 are horizontal from each other, and that's going to be a 0 slope. Lots of good discussion, guys. Any other questions? Anything we want to talk about before we go practice?
Oh, that's the only slide we're doing?
Yeah, that's the only slide we're doing. This is pretty much it for the day. So if we go into day 3 again, I think I have a pair deck practice for us. So I'd like to do the pair deck practice. And the first handful of slides are just going to be kind of discussion points. There's no right or wrong answer with these. So click on that pair deck link. And I think if I did it the way I think I did, we should be able to drag dots into those 4 quadrants. And I want to know which one you think is different. And even if you're sitting at home, kind of talk out loud. Where would you drag the dot and why? Because using the vocabulary is our most important thing here. Is that the first slide? So which one of these lines is different? Which one doesn't belong and why? Bottom right. Why is this one different? It's a negative slope. Absolutely. It is a negative slope. Anybody have a different choice? Which one's different? There's lots of different ways. How's this one? There's no specific answer. You can justify each of these four corners. The second one, like which quadrant are we talking about? Upper right, upper left? Second quadrant. Okay, this guy, how's that one different? This one, first quadrant? Absolutely. This is the only line that goes through the origin, right? So this one is definitely different because it goes through the origin. This quadrant 4 is different because it's the only negative slope. How is this second quadrant different? It's too perfect. It is perfect, right? It looks like it's got the same, like it's making this little isosceles triangle. So this has a slope of 1. That's definitely different. How is this one different? I feel like this quadrant 3 is the one that's least different. How's this one different? It's all negative for sure. It's only going, like, it only has one intercept. I like it. All right, so let's look at the next one. And again, we're just trying to have some dialogue and use our vocabulary, right? Trying to remember quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if we start with quadrant 1, how is this line different? It goes through the origin. Absolutely. Great math language. So this one goes through the origin. How's quadrant 2 different? And if you're at home, feel free to type in an answer, unmute yourself. How's this one different? Is it a positive slope or a negative slope? It is positive. It has a high elevated slope. So this one is like a big slope, right? Super positive. How's this third quadrant different? It's a bigger triangle. Is it still that perfect triangle? I liked how, Miriam, you described it, I think, as being a little too perfect, right? This side of the triangle and this side of the triangle look the same. That means it's going to have almost the same rise and run. Those numbers are going to be almost exactly the same. In fact, I think it's 1. And then how is this one different? What do we call these things where they cross the x and the y axis? It starts with an I. Integers, if they're whole numbers, for sure. I think there's another word. Intervals? No. Intercepts? Intercepts? Can we call them intercepts? So this one has a negative y-intercept. I think it's the only one with a negative y-intercept. All right, what if we have 2 lines? Which one's the most different here? Quadrant 1, quadrant 2, quadrant 3, or quadrant 4? So I heard quadrant 1 and quadrant 3 at the same time. How is quadrant 1 different? They're negative slopes. So this pair is the only pair that has a negative slope. How's quadrant 3 different? Absolutely. If I look at the interior part of these parallel lines, those look like they're never going to touch. And these look like they're never going to touch. These are never going to touch. But I think these are going to intersect way down here, probably somewhere close to the word drag, right? So we've got 3 pairs of parallel lines and then 1 pair of not parallel lines. That's going to be important for tomorrow. Which one doesn't belong here? Which one's the most obvious that doesn't belong? Quadrant 2. Quadrant 2 does not have an intercept. So this is going to be one of those that goes through the origin. If it doesn't have a number here at the end, it's going to go through the origin. Anything else jump at you as different? Quadrant 1, Quadrant 2, Quadrant 3, or Quadrant 4? How's Quadrant 1 different? The slope is 1. Where do I find the slope in an equation? The number before the x. So here there's an invisible 1. I love it. So this, the slope is going to be 4. This, the slope is going to be -2. And this is going to be 3. Okay, so we can always look at the slope. Anything else different? Yeah, why is Quadrant 3 different? It's got a negative slope. So that -2 means it's going to have a negative slope over here. We could. So what's different about 4? The y is negative. So this is going to have an intercept of -1. It's going to cross way down here at -1. Nice. I'm so impressed that you guys remember the anatomy of your equations. Come on now. Let me get to my next slide. I wonder if it'll let me go that way. So here, similarly, and I think this is our last one. So our conversation is coming to a close. How are these different? Or maybe which two are similar? Quadrant 1 has a negative slope. Yeah, so these are going to be parallel. The y-intercept is going to be different, and we can see that with that leading coefficient number, right? What else? There's a fraction down here. So whole numbers are going to be really steep, whether they're positive or negative, and then fractions are going to be really flat, right? So that's another kind of similarity and difference. So let's go ahead and do these. I'm going to stop sharing so you have full control over your screen. Remember y minus y over x minus x, y minus y over x minus x. And if you want to plot them, you can definitely plot them. I encourage that. So -3, 1, 2, 3, 4. That's going to be this one. And then 3, 1, 3, 1 is going to be this one. Zoom. So if I go to do this, 3, 1, I go +3, +1, -3, 4, -3, +4. So make sure you've kind of got great stuff going on. We can do our line tool, and I saw a lot of people doing this. So if I go down 3 and then right 7, this is -3 because I've gone down. And then right 7 is +7. So this is going to be -3 over 7. If I do the formula, then I'm going to do y minus y. So 4 minus 1 divided by -3, -3 minus 3. 4 minus 1 and -3, 3. You got to use all 4 numbers. Sometimes that's another place where people get messed up. They use the same number twice somehow. So 4 minus 1 is going to be 3, and -3 minus 3, -6. This is going to reduce to 1 over 2, and it's a negative slope. That's the other thing you want to be aware of. If this is a negative slope, it's going down and to the right. This is a negative slope. So always go back to your answer and make sure it even makes sense, right? If you graph this, you can eliminate any positive slope choices that you've got going on. What do we get for this one? Anybody got an answer? -4, +5 is kind of off our grid up here. 3, 1. Is it going to be a positive slope or a negative slope? It is a negative slope, so we already know it's going to be negative. We can predict that. My final answer is going to be negative. Let's do the algebra. So y minus y, 5 minus 1, 5 minus 1 over -4 minus 3. -4 minus 3. So 5 minus 1 is 4. And then -4 minus 3 more is my -7, right? And if we graph that, it's going to go 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, -4, 7. Right? Let's just do a couple more just to make sure. What ordered pair do we want to start with? The -8, -2, or the 6, +8? Does it matter? It doesn't. Usually I start with a positive y. That's how I make my choice. So if I start with a positive y, I'm going to do 8 minus -2. Notice how I did that. I did minus and a negative and made it a plus. If I start with my 8, I have to start with a -6. -6, again, minus -8. When you subtract a negative, it turns into a positive. So then I've got 10 over 2. And 10 over 2 makes 5. I can double check that. -8. Oh, maybe I can't do that. -8, -2. I'm just going to make this double, right? And then -6, 8, -6, and 8. So 1, 2, 3, 4, 5, 1. Yep. Okay. Do we like to graph or do we like to do the algebra? Does anybody have a preference? Who likes to graph?
When the graph's not given.
Okay, so when the graph is given to you, maybe use the graph, and when the graph's not given to you, do the algebra. Okay, so again, I'm always going to start with my positive y. That's just how I do it. 5 minus -1, and then I got to start with my -2, -2 minus 6. 5 plus 1 is 6, and then -2 minus 6 is -8. That's going to reduce to 3 over -4. Note that I can have the -3 over 4 or the -3 over +4. All three of these fractions are exactly the same. When you get to chemistry, you'll know that electrons can kind of float around in an atom. They're the same way here. That little electron, that little negative sign can float around, and it can be by the denominator, by the fraction, or by the numerator. I'm looking at the chat because I see somebody chatted something. So this is what we're going to do next is the IXL. I don't want you to labor over this pair deck because I know it can be frustrating. What I'd like for you to do now is go to E2 and do E2 in IXL. So E2 IXL is going to look almost exactly like this. And it goes fast, right? It goes fast. There are a lot of D like dog and E like elephant skills in IXL highlighted. We won't do all of them this term just because of time. I'm not going to teach you everything in them. So it was D3 and D4 that were for last week, and it's going to be E2 and E5 for this week. But I will count for extra credit any Ds and any Es that you do. They're going to go on next quarter, though. Say it again, Jacob. Just D3 and D4 were for last week for the parallel lines and angles, like the angle pairs. But E2 is what we're going to work on right now. E2. It was optional, Morgan. Yeah, I'm just saying where the practice was. So E2 is what we're going to do now. I'm going to give you some time to do that. Slope of lines. Everybody should be working on E2.
When it asks you the slope of a line, it doesn't give you the exact y equals -3x.
So you can also go to Desmos. So if it gives you an equation, open your Desmo graphing calculator. And you can put in, oh, why did it give me all of these things? Why did it give me that? I think I opened the wrong thing. So if it gives you an equation, you can just type it in. Y equals 3x minus 2. And then you can find the slope that way. Mm-hmm. So what are your ordered pairs? 10, 8, and 6, 3. So if you want a visual, you can always pull it up. This is just going to be 1, 2, 3, 4, 5 over 1, 2, 3, 4. Yes. So now I understand. If you do the other way around, if you do like -5 over -4, a negative divided by a negative is a positive. Yeah, good question. So going to bring up my screencastify. Where are you, screencastify?